In the next example on our sheet, the second example, we have the longest shot in a golf tournament was made by Mike Austin in 1974. The ball went a distance of 471 meters. Suppose the ball was shot horizontally off a cliff at 80.0 meters per second. Calculate the height of the cliff. Okay? So again, we just have something shot off horizontally. Alright? There's my cliff. Here's the trajectory of it. Okay? Let's start collecting the information that we know about this situation. Alright, the ball went a distance of 471 meters. Right? So one thing we can say is that we've got a distance, x is 471 meters. Alright, this is what we know about the x direction. Suppose the ball was shot horizontally off a cliff at 80.0 meters per second. So we also know an initial velocity in the x direction. Well, remember, as a vector, this is just the first velocity that it has. Its velocity is 80 meters per second at 0 degrees. Now we can see that this is just the x component of velocity through the entirety of the trip. Right? Again, nothing to slow it down, nothing to speed it up in the x direction. Vy naught is important also in this case. Again, if it's shot off horizontally and you're the guy standing right there, you see something just go straight down with 0 initial velocity. Again, thank you for making our calculations just a little bit easier. And this is what we know in this case. In this case, we don't know y, which is what we're looking for here. So, we got to see what we have to do to find it. Now, we're asked for y, and we're going to have to look at all of the equations that we have in the y direction. Okay. Such as y equals y naught plus v average t, vy equals vy naught plus v t, y So taking a look at this, we can make some simplifications because we know v1 naught is 0. Alright. That's the best we've got so far. Alright. We'll make y naught 0 also. Okay. I think we can rule this one out right away because it tells us nothing about the displacement in the y direction. Here we have a possibility for the displacement in the y direction, y equals 1/2 gt squared. If only we knew the time, we can do that. Here, if we knew the average velocity, well, we'd have to know the final velocity, and the only thing we can use to find the final velocity would be the height of the cliff. So these two aren't going to help us. We're going to have to use this bit right here. So we know that y is equal to 1/2 gt squared. And we'll notice that we can't do this. We know g, that's no real problem because it's fired horizontally and it looks like something just dropped straight down. We're taking g as positive 9.80 meters per second squared. We need the time. In order to use this and find y, we need the time. Here's where we go and say, okay, what's happening in the x direction now? Will the x direction help us find the time? Remember, the x direction has just one equation to work with. X is vx times t. And we'll see that we know x, and we also know vx as well. So we can solve this to get the time. Alright, so we can see that the time is simply x over be x in this case. If we put that into our calculators, we'll see that the time is equal to, what's the time equal to? 5.8875 seconds. Remember, keep that in your calculator. We're going to use that up here. Now, we know the time, we know the acceleration of the ball, we can put those numbers into our equation there, which I'll trust you know how to do, and we'll see that y, the height of the cliff, is going to be 170.0203 meters. We'll round that to just 170 meters. And we got it. So once again, we see a situation where here's what we're asked for, and we don't have everything we need. The time, again, is very much what connects these two sets of equations. We look back at what's happened in the x direction, and we can see, we know this and this. We can solve for the time with the information from the x direction and use it for what we need in the y direction. All right?